This is a follow-up video to my response to Munecat quote-unquote debunking evolutionary psychology. Today we're going to be looking at some data, particularly on sex differences in spatial reasoning, and seeing how the hypothesis is tested, since Munecat seems to think you can't test evolutionary hypotheses. I'm going to go into depth and show you what Munecat did not, because in her video she declined to give an actual methodological and data-driven critique of the question of spatial reasoning. I'm relying on Silverman et al. 2007, which gave an online test to a huge sample of 250,000 people and recorded the male and female scores on the tests. The basic punchline of this study is that the male advantage is consistent across countries and cultures, so the hypothesis that the male advantage is caused by sociocultural factors or discrimination is very unlikely to be true. But Silverman also gives us a very useful review of the evolutionary psychology behind these sex differences. The study is called The Hunter-Gatherer Theory of Sex Differences in Spatial Abilities, Data from 40 Countries. First, men are consistently better at tasks of mental rotation and perform better on maze tests where they must reach a target location and then find the shortest path back to home, replicating common hunting tasks such as tracking prey through random environments and finding one's way back home. This is consistent with the hypothesis that men evolved better spatial reasoning skills due to the time they spent specializing in hunting. Women are consistently better than men at remembering the location of objects in array tests. For example, participants are asked to wait in a room and are either told that they will be tested on the type and location of objects, or they're just told that it's a waiting room and then they're tested. Women consistently outperform men in remembering what objects were in the room and where they were, which is consistent with the theory that women have evolved proficiency at skills that might be useful while gathering, since remembering where edible plants are in the home range would be adaptive. The difference in male and female direction finding has also been tested. Men are more likely to rely on cardinal directions, while women are more likely to rely on landmarks. This was found in numerous studies, for example, Choi and Silverman 1996 and 2003, or Dabbs et al. 1998. Cardinal direction finding would likely be more useful in unfamiliar or distant places, while landmark direction finding would be more useful within the gathering range of a tribe. You might be tempted to think that the reason for this is because men and women were raised to use different forms of direction finding, but there is contrary evidence to that hypothesis. In the first place, I can't think of any special conditioning men receive that might cause them to think cardinally rather than in terms of landmarks. And second, evidence shows that it's likely that men and women are relying on well-developed evolutionary mechanisms for direction finding that are basically innate to them. Choi and Silverman 1996 and 2003 found that when men are told to rely on landmark direction finding, they were not as successful as when they relied on cardinal direction finding, and the opposite was true for females. Both groups ultimately performed just as well with their respective strategies. Munecat contended that the differences in male and female performance in spatial reasoning tasks are the result of cultural conditioning. This sounds like it could be true, but what she didn't say in the video is that there is actually cross-species evidence for a male advantage on spatial reasoning. Male wild and laboratory rodents perform better at maze learning tasks than female rodents, as per Barrett and Ray 1970, Benny Dawson and Ching 1982, Gollin and Fitzgerald 1986, Joseph Hess and Biracree 1978, and Williams and Meck 1991. Additionally, rats exhibit the same difference in navigational strategy as human males and females. Male rats navigate by the shape of rooms, while females require landmarks. You might be curious how researchers determine this. In Williams et al. 1990, Organizational Effects of Early Gonadosecretions on Sexual Differentiation and Spatial Memory, two cues were used to allow rats to navigate, landmarks as well as room geometry. Scientists changed these and noted the rats' performances, and found that changing room geometry disrupted male rats, while changing landmarks disrupted female rats. This pattern matches what was hypothesized about directional navigation strategies in humans, men navigating cardinally and women navigating through landmarks. Of course, this might prove that a male advantage in mental rotation is innate rather than cultural, but it doesn't prove the hunter-gatherer hypothesis of male and female differentiation on spatial reasoning. Nonetheless, in this evidence, Akira, Dabb, and Robert found that an advantage in remembering and navigation by landmarks may have helped females avoid predators, and so a similar kind of selection may have occurred in other species. Other data supports an evolutionary explanation of male spatial reasoning ability. Studies on rats such as Taub 1995 or O'Keefe and Nadell 1978 found that distinct brain sites are activated when male and female rats navigate. In one human clinical study, Pizzamiglio, Gariglia, and Costantino 1998 found that patients with a damaged right hemisphere could not navigate a room unless they used landmarks. Now, what's interesting about this is that Munecat claimed an evolutionary hypothesis cannot be tested. However, we have just seen a hypothesis about sex differences in navigational ability and spatial reasoning can be tested. A prediction was made that men are going to be better than women at tests of spatial reasoning that are akin to those tasks men would be doing while going out hunting. Tests were conducted. The way men and women navigate environments was tested, showing that men navigate cardinally while women navigate via landmarks. These results are compared to the hypothesis, and it was found to agree. This easily could have been falsified if, for example, studies showed no differences in navigational strategy between men and women, or if studies showed no male advantage in navigation. And although the animal studies do not offer proof of the hunter-gatherer hypothesis, they do at least prove that the basic premise of the hypothesis, that there will be evolutionary sex differences in navigational ability, is true. There, we've just seen an evolutionary psychology hypothesis tested, as well as the knock-on effects that might extend from the original hypothesis, i.e., women are going to be better at memory-related tasks. This suggests that females perform well within their home range, which is consistent with the hunter-gatherer hypothesis. Silverman's actual study gives interesting evidence that suggests the male advantage in spatial reasoning is innate and therefore the product of differential selection pressures, since it's pretty consistent across cultures and locations. The female advantage at object memory was consistent. The effect size for the male advantage was 0.48, and the effect size for the female advantage was 0.31. Silverman states, "The test of correlation between effect sizes for male and female biased tests provided no support for the notion that society-based, sex role stereotyping practices are relevant to sex-related spatial differences, nor did the correlations for both tests between GNI and effect sizes replicate prior findings of a socioeconomic status factor. None of this, however, implies the absence of an environmental role in the ontogeny of spatial sex differences. It is well recognized in contemporary evolutionary psychology that innate dispositions always manifest themselves in environmental contexts. The present data, however, might encourage researchers in sex differences that are universally found to abandon the issue of heredity versus environment and focus on what is inherited and how it is expressed." So we can see here that the theory posited by evolutionary psychologists isn't an ad hoc just so story in any way. It's backed up by empirical testing, psychological testing, cross-species evidence, and it's reasoned based on the knock-on effects you can predict from differential selection of the trait. This is something of a synecdoche for how evolutionary psychology operates. The best studies have empirical data, they have reasoning based on non-arbitrary predictions from a trait, and they can well establish a probable evolutionary history behind a given trait. The fact of the matter is that scientists in evolutionary psychology have available multiple methods to test and falsify their hypotheses. Munecat made it seem as if they were simply making up stories, and I think one reason for this is because she was mostly reading introductory textbooks. I had to look at them myself, namely Evolutionary Explanations for Human Behavior, as well as Gary's Male-Female, The Evolution of Human Sex Differences. The books don't go into any methodological depth and are basically just gestalts of the studies in question, so I can see why you might get that impression if you decline to actually investigate the studies themselves. Like all introductory textbooks, it's very narrative-heavy and simplified for an audience completely new to the field. It's supposed to be a crash course, not part of an academic defense of the field. Munecat saw the narratives and decided that they were all that existed, and proceeded to create her own narrative about evolutionary theories being untestable just so stories. I hope you can now see that she's wrong. If you're still convinced it's impossible to test an evolutionary hypothesis, let's take a look at some methods that evolutionary psychologists employ. I consulted ChatGPT to come up with a list, and here's what it found. First, we have cross-cultural studies, which we've just seen in Silverman et al., where he tested spatial reasoning and memory in several countries around the world. If a trait is consistent across cultures, then that constitutes evidence that the trait may be the result of evolutionary selection. Second, there are comparative studies like cross-species study of a trait. Again, we've seen these. If a trait shows up in both humans and animals, it suggests an evolutionary origin, just as a male advantage in spatial reasoning and a specific male-type pattern of cardinal navigation was found in rats as well as humans. Third, there are experimental studies. These would be the most useful, but also the least practical, since it would take a very long time to actually conduct one, such as by altering the selection pressures for a population. Fourth, there are neuroscientific studies, which we've also seen here on rats. Data on brain structure and activation patterns can reveal potential evolutionary origins of traits and behaviors. Fifth, we have behavioral genetics, which means like twin studies, adoption studies, and genome-wide association tests. These provide strong evidence for the heritability of traits. One example is the Minnesota Transracial Adoption Study, which will establish the heritability of intelligence. And sixth, we have mathematical modeling, which I don't know that much about, but it allows scientists to simulate potential paths of evolutionary selection to determine the probable history of a trait. So there we have it, at least 6 ways scientists in evolutionary psychology can test and falsify hypotheses. Munecat is just wrong. She's a person who says wrong things. She blithely makes claims and spins narratives without doing the most cursory amount of research that would be required to actually investigate them. Her belief that evolutionary psychology is an invalid field of science is essentially just a product of her lack of knowledge about it, combined with her preconceived ideological agenda, which is egalitarianism. There's really no excuse, because if I could figure this out from one study, and with a simple chat GPT query, she could have figured it out in minutes too. She's saying very irresponsible things and spreading misinformation about science. Munecat is essentially arguing for creationism. We know that every gene in the human body has been under selection pressure since the very beginning. The brain was under these selection pressures, which is important because the probability that major parts of human behavior are purely sociocultural in origin is 0. All behaviors are at least somewhat heritable. That's the iron law of behavioral genetics. Evolution did not stop at the neck. When you're on the side of the creationists, flagrantly denying human evolution in the brain, you have to check whether you're actually engaging in good faith with science. Human evolution is well established. The heritability of behaviors is well established. It's time for a sanity check.